Okay, so your homework. So question number says one says, what is the magnetic field strength 5 centimeters from a wire which is carrying a current of 58 amps? So you're going to use B equals mu OI over 2 pi r, the equation that we learned yesterday. Okay, and so B is equal to mu O is 4 pi times 10 to the negative 7 Tesla meters per amp. You're going to multiply that by 58 amps, and then it gets divided by 2 pi r, but the r is in centimeters, so change it to meters, so 0.05 of a meter. And then, again, like I said yesterday, I would cancel the 2 pi, and then you only have to fill into your calculator 2 times 10 to the negative 7. And you're multiplying that by 58, and you're dividing that by 0.05. And you should be getting 2.32 times 10 to the negative, I think that's 4, okay, Teslas. So that's the first part of the question. 1, 2, 3, yeah, it's 4. Second part wants to know if the wire is running east to west and the electron current is flowing to the east, what is the direction of the magnetic field above the wire? So you're going to use the first hand rule that we did. Point your thumb in the direction of the electron flow. Your fingers curl in the direction of the magnetic field. So above the wire, your fingers are going into the board. So the answer would be into, I guess not board, page, into page. Okay, so that's question number 1. Question number 2 says, if a current carrying wire sets up a magnetic field around itself when it's 8 millimeters from the wire, what is the current flow? So for the first part, again we're doing B equals mu OI over 2 pi r, but this time we're rearranging for I. So I will end up being 2 pi r times B over mu O. So I will equal 2 pi. R is 8 millimeters, or 8 times 10 to the negative 3 meters. B is 1.505 to the negative 4 Teslas. And then mu O is 4 pi times 10 to the negative 7 Tesla meters per amp. So again, this 2 pi, this 4 pi becomes 2, and so you are doing 8 to the negative 3 times 1.505 to the negative 4, and then you are dividing by 2 to the negative 7. And you should get, it might be 602, but I can't see where the decimal is. 6.02. Okay. So your I is 6.02 amps. Second part of the question says, what's the resistance if the voltage is 120 volts? So you're going to use Ohm's law, V equals IR, that you all saw in grade 9, and then some of you saw last semester that we reviewed at the beginning of this semester. So it is one that will come up in this unit because it's a fairly simple one. We want to solve for R, so divide by I. Please rearrange this correctly. So 120 volts divided by 6.02 amps is going to give you a resistance of something just slightly less than 20. 19.9335 ohms, or 934 ohms. Okay, that's number 2. Number 3. Number 3 says a wire carrying a current. How far from the wire is the magnetic field? Okay, so this time it wants you to find R. How far away? So again, you're doing B equals mu OI over 2 pi r, but you're rearranging for R. So mu OI over 2 pi B. So 4 pi times 10 to the negative 7 Tesla meters per amp. I was 90 amps over 2 pi times 1.8 times 10 to the negative 4 Teslas. Again, the 2 pi, 4 pi, this becomes 2. So on the top, it's just 180 to the negative 7. And on the bottom, you are dividing by 1.8. Ooh, could do this in your head. To the negative 4. And, if I didn't screw up, you get 0.1. So R is equal to 0.1 of a meter. Okay, second part of the question says the wire's running north to south. The field's going into the page on the west side. What is the direction of the conventional current? So the wire's running north to south into the page over here, means out of the page over here. Conventional current, take your right hand, curl your fingers. Your thumb would be pointing this away. Whoops. Current is going to the south would be the answer. Okay? Last question, number 4. Number 4 starts off by giving us a resistance and a voltage. So from that we can find a current. Again, V equals IR. So I is equal to V over R. Higher order math. 240 divided by 40 might give you about 6 amps. And then it tells us radius, and it wants magnetic field. So B is equal to mu OI over 2 pi R. Mu O 4 pi to the negative 7 Tesla meters per amp. I is 6 amps. That really is an A. Over 2 pi times, and it's 0.3 millimeters, so 0.3 times 10 to the negative 3. That's really close. B, my paper's moving, is equal to, so again, the 2 pi, 4 pi just becomes 2, so 2 to the negative 7 times 6, that's about 12 to the negative 7, and then you're going to divide that by 0.3 to the negative 3. Again, you could do this in your head. Might have screwed up. Maybe I should have done it in my head as I was punching it in the calculator. 12 to the negative 7 divided by 0.3 to the negative 3. Oh, no, I got the same answer. 0.004 Teslas. I think there's a direction on this one too. If it's lying in front of you on the desk, this wire, and the current is flowing away from you. So I might draw this like this, because if it's flowing away from you, then it's doing this, and it's going like into the page away from me. And it does say that it's electron current, and it wants to know what will be the direction of the magnetic field. So the magnetic field is going to be around this wire. So take your left hand, because it's electron current, put your thumb away from you, and your fingers are going to curl this way. Okay? Alright, there you go. There were the 4 homework questions from last night. Please do the ones I assigned in the last video today. We'll go over them tomorrow. And we have another hand rule to learn, and probably a little hand rule quiz just to see how good you are. Alright, have a great day. See you tomorrow.